All right, grade 6. We are moving along. Our big idea continues to be understanding operations, adding, subtracting, multiplying, and dividing helps us to solve problems in the real world. Today, we are going to work on demonstrating an understanding of division with decimals with a one-digit divisor. You will be looking at the Connect section of Unit 3, Lessons 5 to 6, actually. Not 7, 5 to 6. So we're going to start with Lesson 5, which is dividing a decimal by a whole number. All right, so let's take a look at our first example. We have a small town in Manitoba, and every August there is a frog jumping contest. The longest jump on record is 5.8 meters. So here we have Rochelle, who entered 3 frogs into the frog jumping contest. The total distance the frogs traveled was 4.92 meters, or 4 92/100ths of a meter. How far did each frog travel? So we need to divide. So she's decided to use base 10 blocks, and on the side here we're using the long division algorithm method. Oops, can't fit my M. Let's redo that here. All right. With the algorithm method, we have to use our estimate, multiply, subtract, bring down. Estimate, multiply, subtract, bring down. Okay. So let's take a look at what they've done here. First of all, with base 10 blocks, and then we'll connect that to what they've done over here in the algorithm method. So they started off with showing 4 wholes, which they've had as the flats, 9 tenths, which are the tens rods here, and then 2 hundredths, which are the little cubes. So here we go. Now she's trying to create them into groups of 3. So she's going to rearrange it so her whole number is divided into groups of 3. And we have 1 complete group. So here you can see there's 1 group of 3, which is 3. We take that away, we're left with 1. So here's the 1 that we have left. Okay. Now we're going to have to bring down. So now she's taking the 1 that she has left and she's traded it in for the rods. So there are now 19 tenths, which is what she's done because she's brought down the 9, so we're left with 19 here. Okay, so now we have 19, we have to divide into 3 groups, which she's done here, 3 groups of 6. So and we can see here she's divided them into groups of 3 here, of 6. Sorry, I was looking at the other picture. So we have 6 groups. 3 times 6 is 18. What are we left with? We're left with 1. Here's the 1 that we're left with. She trades this now in for cubes, and she ends up with this many, little cubes, and she can divide that into equal groups. So we've got there 12, and she's been able to divide them into 3 groups of 4. So 4 times 3 is 12. So let's review the algorithm method here on its own without the base 10 blocks, just to confirm what we've done. So we ignore the decimal to begin with, and we say, okay, how many 4s or how many groups of 3 can 4 be split into? Well, only 1 group of 3, so our 1 goes up here. We multiply now. 1 times 3 is 3. Now we subtract. 4 minus 3 is 1. And then we bring down, and that's our new number that we're looking at is the 19. So how many groups of 3 can 19 be split into? Well, we can have 6 groups of 3 groups of 6. which would be 18. 3 times 6 is 18. We subtract. We're left with 1. We bring down again. Our new number is 12. 12 can be split into 3 groups of how much? Well, 3 times 4 is in fact 12. We subtract, we're left with no remainder. Now we need to bring our decimal up to put it back in there. We would have 1 64/100ths of a meter for each frog to have traveled. That's using the algorithm method. Now, we've been doing a fair bit of work with repeated subtraction. So let's try repeated subtraction with the decimal number. And we're just going to completely ignore that decimal for now. Okay, we're going to pretend it's not even there. So 492. Well, how many groups of 3 can fit into 492? Well, I'm going to start with 100 because that's an easy number for me to work with. And I know that 3 times 1 is 3. Add my 2 zeros from annexing 0. I'm left with 300, and I now subtract. 2 take away 0 is 2. 9 take away 0 is 9. 4 take away 3 is 1. I can't fit another 100 in. But I'm going to go 30 because 3 times 3 is 9. Add that 0, that's 90. That's pretty close. Or closer anyways. I'm going to try that. 2, 9 minus 9 is 0. I'm left with 101. Well, maybe another 90. So 3 times 3 is 9, add my 0 is 90, take away 2, I have to borrow here, that becomes 0, this becomes 10, 10 minus 9 is 1, so I have 12 left. Well, I'm going to need 4, 3 times 4 is 12, 0, so now I have to add those up. I'm going to make sure I line them up properly. Oops, look at me. Not 200s, only 100. 2 30s. Let's fix that. So 100, 30, and 30, and 4. Add those up. 4, 6, 1. And now I'm going to use estimation to determine my placement for my decimal because that would be easiest. 4.92 is pretty close to 5, so I'm going to make it 5. And 3, so 5 divided by 3 is going to be about 1.5, so I'm going to place my decimal here. 1.64. So either way you can choose. Repeated subtraction, the decimal placement is a little bit trickier. So if you're placing your decimal in the wrong place and you find algorithm method works quite well for you, then probably for decimal division, stick with algorithm method. Otherwise, you have to use estimation to determine your placement of your decimal. All right, here we have another one to look at. Here we have Luke's frog, who traveled 16.64 meters in 4 jumps. 4 jumps. About how far did the frog travel in 1 jump? So we want to take 16.64 is 16 64/100ths of a meter and divide it into 4 groups. Here we're going to look at repeated subtraction. Oh look, I just did an example and here's one there for you. Oh well, not bad to do another one. So again, you can see they ignore the decimal. They ignore the decimal and they look at 1,600, and they've started with 100 as well. So 4 times 100 is 400. They've subtracted 1,264. There's another room for another 400, so they put another 400 in there. Another 100 times 4 is 400, subtracted. We still have 864. We can fit another 400 in there, so I'm going to multiply by 100 again. 4 times 100 is 400. Subtract, I'm left with 464. I can fit another 100 in there. 4 times 100 is 400. Subtract, I'm left with 64. Now I can't fit 100 in there. I'm going to go with 10 because that's easy. 4 times 10 is 40. Subtract, I'm left with 24. 4 times what is 24? Well, it's 6. So 4 times 6 is 24. You can see how they've lined all their numbers up properly here. We're left with 416 as the answer there. And again, you're going to use estimation to help you determine decimal placement. So if we know 1664 is close to 16, 16 divided by 4 is 4, we know our answer has to be close to 4. 4.16 would be our answer. We could use multiplication to check. We could multiply 4.16 or 4 and 16 hundredths times 4, and we would see that we would get 16.64 or 16 and 64 hundredths, and our answer would be correct. And here we have another slightly different strategy. He's using estimation to place the decimal point. Again, he divided 1,664, just taking the decimal out, by 4. And 4 is a fairly easy number to divide, especially if it's even places all along. So he's taken 1,664 and divided it into 1,664. 1,000 in 4 groups, what he knows is 250. 600 into 4 groups, he knows is 150. And 64 into 4 groups, he knows is 16. He's added those all up to make the 416. And again, 16 divided by 4, using that estimation strategy, 16 divided by 4 is 4, so he knows he has to place his decimal right after the 4 to make it as close as 4 as possible. All right, we're going to add in lesson 6, which is still dividing decimals. So continuing with division of decimals, not much different here. This is a bit of a trickier strategy, so we need to make sure when we're doing division with decimals that we don't end up with remainders, and that's what this lesson is really about. So I've combined it with the last one because it's not a whole lot different, other than if there is a remainder, you need to use a slightly different strategy and continue to keep working by adding zeros so that there is no remainder. A decimal number cannot have a remainder. So let's take a look at some examples of how we would do this. First, we have our problem. We have 4 hikers who wanted to share a 9.45 liter jug, or 9 and 45 hundredths of a liter jug, equally. So we're taking 9.45 and dividing it by 4. And here we have long division. Sorry, with long division, we are going to begin like we would normally, remembering our estimate, multiply, subtract, bring down strategy. How many groups of 4 can fit into 9? Well, 2 groups, so is our estimate. 4 times 2 is 8. So now we need to subtract. 9 minus 8 is 1. Now we need to bring down is 4, so now we have 14. Well, 4 goes into 14. The closest we can get is 3. That's my estimate. 4 times 3 is 12. So I write my 12 there. That's my multiply. Now I subtract. 4 minus 2 is 2. 1 minus 1 is nothing. So I'm left with 2. I bring down my 5. I don't know why they don't have their bring down arrows. I always find that helpful, so I know I've used that number. All right, so next we're into 25. How many times can 25 be divided by 4? Well, 6. So I'm going to put my 6 up there. 4 times 6 is 24. Subtract. 24 minus 25 is only 1. I need to again bring down. Oh, there's nothing to bring down. So this is when I draw in my 0 and I bring it down. So now I'm left with 10. Okay, so I've had to add that 0. And then I keep going. Now it's 10. 4 times what is close to 10? Well, 2. 4 times 2 is 8. I subtract. I'm left with 2. I have to bring something else down. Again, there's nothing there, so I add in another 0. And I bring it down, and now it's 20. So how many groups of 4 can 20 be divided into? Well, 5. So 4 times 5 is 20. Subtract is 0. I have no remainder left. I'm actually done. Now again, we estimate to place our decimal. So 9 divided by 4, or 9.45 divided by 4 was our original question. And if I look at it, 9 divided by 4, well, it's kind of closer to 8. 8 divided by 4, well, that would be about 2. So it's going to be a little bit more than 2. So I know that I'm going to have to place my decimal after the 2, which would leave me with 2.3625, or 2 362 thousandths and 5 ten thousandths. All right, and then communicating this decimal number, depending on the problem, changes slightly. So when the quotient is a measurement, we give an answer in the form that makes sense. Since the volume of water was given to the 100th of a liter, we would write the quotient, and remember the quotient is the answer, to the closest 100th as well. So we would round 2.36 to or 2.3625 to 2.36 using our rounding rule of course we look at the 6, we look at the 2 tells us that it's less than 4 and we ignore, so it just becomes 2.36. And again, we can always check the answer by using the opposite operation of multiplying the quotient or the answer with the divisor, and we should end up with the dividend. Remember, the dividend is the number that is inside the little box. Okay, so we end up with 2.36, blah, 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 blah. We're rounding those off, so we're not going to worry about those. And 4, and it should end up being 9.45, or in this case, it should be close to that answer because we've rounded that number. Let's take a look at another one. And here they're using a strategy called short division, and I'll have to talk to you a little bit about what that involves. So one morning, the hikers are traveling 10.4 kilometers in 3 hours. How far did the hikers travel in 1 hour? So we're taking 10.4 and dividing it into 3 equal groups so we can see how long it would be in 1 hour. All right, so we've got our question, and again, we just ignore our decimal for now. Completely ignore it. Forget that it's there, okay? In fact, I'm going to erase it. Oh, I guess I can't erase it. All right, well, pretend it's not there. Okay, so 3 times 3, which is 9, is very close to 10. It's in fact only 1 away, so I put my 1 there. Now I'm going into 14 here. So 3 times what is close to 14? Well, 3 times 4 is close to 12. 14 minus 12 is 2. So I put the 2 there. I'm not quite done, so I have to add my zeros to get rid of my decimal. 3 times what is close to 20? Well, 3 times 6 is close to 20. 3 times 6 is 18. 20 minus 18 is 2. So I add another 2. Again, I'm going to have to add a 0 because I'm not quite done yet. 3 times what is close to 20? Well, again, 3 times 6 is close to 20. 3 times 6 is 18. 20 minus 18 is 2. Again, I add another 0. 3, I'm starting to see a pattern here. 3 times what is close to 20? Again, 3 times 6 is close to 20. It's 18. 18 minus 20 is 2. And when we see this start to happen, when we see the same number repeating a minimum of 3 times, has to repeat at least 3 times, we have come across what is called a repeating decimal number. And you'll see this sometimes on your calculator when you divide decimal numbers. You'll end up with a number that ends going, in this case, for example, it would be 34666666666 right to the end of the calculator where it just would continue to do that. So that becomes a repeating decimal. You communicate that like this. So 3.4, and I know it's 3.4 because I'm estimating 3 divided by 10. Well, 3 divided by 10 is close to 9. Or is close to 3 because 3 times 3 is close to 9. So it's going to be 3.4666666. And you don't want to keep writing all those 6's. So the way you would communicate it is 3.46 and put a line over the 6 because the 6 is the part that's repeating. So then it would be 3.46 repeating. All right, so let's just check. We estimated to place the decimal because 3 times 3 is 9, which is close to 10, or 10 divided by 3 would be about 3. This quotient is what we call approximate. It's not actual because we've had to have this repeating decimal. We can't get an actual answer. They indicate here that you can show a repeating decimal with the 3 ellipse dots afterwards. You can, but that's not really common. practice for mathematicians, the common practice for mathematicians is to put a line over the decimal or the digit in the decimal number that is repeating. And it can be more than one digit. You could end up with 3.4646464646, at which point you would put the repeating line over top of the 4 and the 6, not just the 6. Okay? And again, because this in question was the distance was given to the 10th of a kilometer, we would write the quotient or the answer to the closest tenth. So we would round 3.46 repeating to 3.45. Because that's 3.46 is really close to 3.45. Again, to check it, we could multiply. We could multiply 3.5 times 3, and we would end up with 10.5, which is really close to 10.4. And because this is an approximate answer, because we've rounded it due to the repeating decimal, we know that that answer is reasonable. We probably did our math calculations correctly. All right, as always, we're going to do some practice. I accidentally included the practice for lesson 7, so we're not going to worry about those two. We're only going to worry about these 4. So let's start with the first 2. Do the first 2 using whichever strategy you would like. Repeated subtraction, division, long division. You might even want to try some short division. Use whichever strategy you prefer and press pause, do those, and we'll check them after. All right, I'm going to do the first one using repeated subtraction. So 5, I'm going to ignore my decimal. 5 into 625. 5 times 100 will be pretty close. 5 times 100 is 500. Okay, so I'm going to subtract. 5 minus 0 is 0. 2 minus 0 is 0. 6 minus 5, 5 is 1. Okay, 500 isn't going to work. So I'm going to try 5 times 2 because I know that's 10. Add that 0, that's going to make that 100, and 100 is pretty close. So I'm going to subtract. Again, 5 minus 0 is 0. 2 minus 0 is, 5 minus 0 is 5. My mistake. 2 minus 0 is 2. 1 minus 1 is 0. So I'm left with 25. Well, I know 5 times 5 is 25. Subtract, I'm left with 0. So adding those numbers up correctly, 5, 2, 1, 1, 2, 5. 5 divided by 6, well, that's pretty close to 1, actually. It's a little bit more than 1, so I'm going to put my decimal there. 1.25 is what you should have gotten. Whichever strategy you use doesn't matter. That should be the answer that you come up with. All right, I'm going to use long division for 4.424 divided by 4. So how many groups of 4 are going to go into 4? Well, 1. 4 times 4 is 4. So I've estimated, I've multiplied. Now I'm going to subtract and bring down. Subtract is 0. Bring down is 2. 4 times what goes into 2? Well, nothing. And I do have to put that 0 in there. 4 times 0 is 0. 2 minus 0 is 2. Now I bring down my 4. How many times will 4 go into 24? 6 times. 4 times 6 is 24. No remainder. And I bring my decimal straight up. Very important that I've lined my numbers up correctly. Otherwise, my decimal placement will be incorrect. So remember, if that first digit doesn't work, it should be a 0 in front here so that those numbers can all line up correctly. Regardless of what strategy you used, you should have ended up with 1.06. All right, now try these two, 8.235 divided by 6 and 12.6 divided by 5, and use again whatever strategy you prefer, repeated subtraction or division, long division, or even short division if you'd like. Whichever you prefer sounds good to me. Remember, it is good to be able to use more than one strategy. Just makes you a little bit more flexible in your math thinking. All of the strategies should, of course, end up with the same answer. So press pause and try these two now. All right, let's take a look. So we have 8.235 divided by 6. And I'm going to try short division for this one. So how many groups of 6 are going to go into 8? And again, I still use my estimate, multiply, subtract, bring down for this. One group of 6 will go into 8, so that's, I'm not doing the short subtraction, sorry, let me get rid of that. So that's 6 subtracted, 8 by 6 is 2, so that means I'm left with 22. 6 goes into 22, well, closest to 6 times 3, 22 minus 18 is 43, 4, so 43. 6 goes into 43 7 times, because 6 times 7 is 42. That means I'd have 1 left over. 15 now, 6 goes into 15. Not 3 times, only 2 times. 6 times 2 is 12, which means I'm going to have 3. I can't have a remainder, so I have to add a 0. 6 times what is close to 3? 6 times 5 is close to 3. And at that point I will end up with 0, so I can stop. So 1, 3, 7, 2, 5 is my answer. I need to place my decimal. I can just bring it straight up as long as I've placed my numbers correctly. I can estimate to confirm that my decimal is placed in the right spot. 6 divided by 8. Well, 6 is pretty close to 8. It's going to be 1 and a little bit more. So 1.3725 makes perfect sense. All right, let's take a look at our last one. 5 into 1, 2, 6. With the decimal there, I'm going to ignore it. I'm going to use repeated subtraction for this one. 5 times what is close to 126, or even close to 100? Well, it can't be 5 times 100 because that's 500. I guess I'll go 5 times 10 this time. 5 times 10 is 50. I'm going to subtract. 6 minus 0 is 6. Can't take 5 away from 2, so I have to borrow. 1 becomes 0. 2 becomes 12. 12 minus 5 is 7. I could take another 50 out of that. So I'm going to go with 10 again. 10 times 5 is 50 because 5 times 1 is 5. Annexing 0, we add that 0 back on. We subtract. 6 minus 0 is still 6. 7 minus 5 is 2, so I'm left with 26. Which means I need to have 5. 5 times 5 is 25. Now I can't continue on with the remainder, so just one sec. Alright, so I've added my box on there, because otherwise I've got numbers underneath. So I'm left with 1. I have to add a 0. 5 times 2 is going to be 10. And I wonder what happens with my adding. Let's check and see if this is going to work. So 10 plus 10 plus 5. I suspect the 2 is over here. Oops. 2. Yeah, that 2 has to be moved over because we've added that 0. So in fact, that 2 has to be like a tenth here, almost. Like it has to be moved over a bit. It's in the next place because I know that 5 divided by 12 is going to be about 2 something. So 252, 2.52 would be my answer there. So if I was doing this with repeated subtraction, I think I would probably do columns in here, move my 5 over here, and move my 2 over here. So when I start to add zeros, I would be moving each one over one more because we're moving them decimal places over. That could get a little bit tricky when you're using repeated subtraction with decimal numbers when you're adding that 0. So be really careful when you're using that strategy. Perhaps try one and show it to me to make sure that you're on the right track with that. All right, at this point, you are on to the concept practice. And again, I've changed something a little bit. I've taken lesson 7 out. So you don't have to do that part right now. We'll do that next day. We're going to just start with dividing with decimal numbers here. And here it's going to be dividing with decimal numbers and adding the 0 so that there's no remainders. So those are our 2 differences for those 2 pages. Remember when you're doing the adding of the zeros to get rid of the remainder and you're using repeated subtraction, that you come and show me some to make sure that you're on the right track. In case you've misplaced your textbook, a number of you have been starting to do that, unfortunately, and as a result, not getting your homework done. So to help you out, here is the pages from the textbook that you need to use. I'll just flip through them, and you can press pause as you work. So there's 1. Here's 6 and 7. Here's the next lesson. And here is the last one. So that should help. All right, and here's the second set of pages from lesson 6. And there's the last one. And then once those have been marked and you see that you're on the right track, you can move on to the beginning of the exit slip. Just do the first 2 rows here. This will be done after our next lesson.